Hey everybody, it's Mr. Mott. We're going to go through the modeling portion of our lead nitrate and potassium iodide experiment. In this portion, what we try to do is try to envision why we think the reaction happened the way that we did. In this model, I'll first kind of show you what we don't want you to do. So in the experiment, when we added the lead nitrate and we added 6 drops to the left-hand side of our Petri dish, and we added 6 drops of the potassium iodide on the right-hand side, what we saw happening was that typically in the middle, we formed this yellow substance, and then we also saw that it became a little bit more faint around the edges as the experiment happened. I would say that these are not the things that we would want to draw on a micro scale model like we had. That's sort of what we would draw if we didn't have the luxury of a camera or a video recording device to be able to capture what we had. What we want to do is we want to try to envision the particles moving and how we would represent that. Okay. The analogy I used in class is that, like, if you were Ant-Man and you can squeeze down into a much smaller space and actually see the particles moving. When you do modeling, what you try to do is that you try to either use different symbols and or different colors to represent the particles moving. So on the left-hand side, this is just one way of approaching it, and you may have some different and better ideas. One way of approaching it is to use some different symbols. So for the lead nitrate, I'm going to include some circles for the particles. And what I chose to do here is to have 6 circles because we added 6 drops. On the potassium iodide side, I'm going to use a different symbol and a different color for this. And I'm going to use some triangles. And if I'm going to stick with the theme of having 6 drops and 6 triangles there, that's what I'm going to do. If you wanted to add more on there, you certainly could, but just keeping in mind the number of drops may equal the number of particles. We're not sure. To envision that, we know that we had a reaction in the center where things turned yellow. So we could maybe kind of use our highlighter function and put make this yellow here in the middle is generally where you would see the reaction take place. And so something to think about is that when we added the drops of, say, potassium iodide into the water, a reaction didn't take place. Likewise, when we add the lead nitrate to the water on the left-hand side, a reaction didn't take place. We didn't see any change. In order to have a change that happened in the center, what we can infer is that these particles, the lead nitrate and the potassium iodide, move towards the center. And so for that, I think a critical thing that we would want to add is that we would want to add something to indicate particle movement. Okay? And so we could indicate arrows showing that the particles moved. Okay? You could represent this in other ways. This is just sort of how I'm choosing to represent the movement. But you definitely, in a model, if you think there's movement happening, you want some way of identifying or demonstrating that movement. Okay? Now, if I wanted to then still represent on a small scale what made this yellow, because I would consider the yellow portion to be sort of a big scale idea. What I might try to insinuate here is that in the center, I probably had, this is where the lead particles went to, 1, 2, 3, 4, 5, 6. And what I'm also sort of maybe insinuating is that there was a reaction that took place between those particles and the potassium iodide. And so what I'm going to then draw is maybe a triangle attached to the circle, the triangle again being the potassium iodide particles. So when I came to, when I first started thinking about this and how I would draw this, this is sort of the idea that I came up with. I've seen some different variations of it, but I think a lot of the main ideas that we would want to include. So in any type of modeling, when you're trying to differentiate between one particle and another, let's make them different colors and or different shapes like we have. To indicate movement, arrows or some other way of indicating movement would be there. If I think a chemical reaction took place, I'm seeing that our particles have combined. And then to signify that a different color took place, that's why I have the yellow here. Okay? And this would be the beginning stages of our model. And these are some typical kind of components. Now, for our lab, what we're going to do later on, as we learn more about the nature of a lead nitrate solution and the nature of a potassium iodide solution, we'll update our models. And the way that we represent our particles is going to be different. But for now, these are the basics of modeling, and thanks for watching our video.